at the metric system here on the bottom of page 252. So outside of the United States, science's everyday life is based on the metric system. And so it's the universal set of units that scientists from around the world, even here in the United States, use to be consistent with each other. And so for us, sometimes it's a little bit confusing because our everyday lives are not metric units, they're the imperial, versus when you come to science class, all of a sudden you have to use this other set of units and measuring system. So take a look. In our Regents chemistry, we have two reference tables that we tend to overlook and not pay much attention to, but they can help us with this. So first off, there is reference table D on the very front page. And on reference table D, number 1, you will see the names of the quantities that we tend to measure in chemistry. I'm just going to put quant for quantities. And that would be examples like things that we tend to measure would be something like mass, volume, time. Just 3 examples. But also on this table, it also names the basic metric unit. So comma, it names the unit and provides the unit symbol. So it names the unit, that should say names the unit, and it supplies the symbol. So when you come across a number that's tagged with a unit, so let's just say that it's 43.6 H, well, you recognize this is a value, and and this looks like a random letter. You need to think, okay, what is that? That must be a symbol to put this number into context. So when you go to your table D, you look down your first column unit symbols, you'll see H, and then you move over a column and it'll tell you, oh, H stands for hour. Well, hour is one way to represent time, the quantity. The other table that we have here is table C, and this is simply a list of the prefixes, of our metric prefixes. And these metric prefixes and how they relate to the base unit. So let's start here with the base unit. So when I see the base unit, these are main examples. These are the quantities on table D. So these are the quantities and units that we see listed on that table D. So a base unit would be gram or liter, mole. MOL is the symbol for mole. A capital P, lowercase a, is the symbol for Pascal, unit we'll get to when we start talking about pressure, right? Base unit of S4 seconds. There's many others. Oh, we did energy, so we have a base unit of capital J to quantify the amount of energy. And so when we have the base, this is our standard, this is our reference, and its factor, what it represents, is 10 to the 0. And 10 to the 0 simply means a value of 1. Anything raised to the 0 power, it makes it 1. So 10 to the 0 is defined as 1. So that's our standard. Okay, so now let's talk about the prefix names and their symbols. So 3 of our prefixes start with the letter M: mega, milli, and micro. There are small variations in their symbols. So if it's mega, it's a capital M. If it's milli, then it's a lowercase m. And if it's micro, it's not even an M. It looks like a U, so I'm going to write a lowercase u, but a lot of times it has that little tail out in the front. It's the Greek letter mu. All of the other ones are pretty simple. So kilo is a lowercase k, deci is a lowercase d, centi is represented by a lowercase c, nano by a lowercase n, and pico by a lowercase p. Don't make up your unit symbols, then they're wrong. But here is the part that often is overlooked or what people don't understand. What does that capital M symbol for mega, what does it really mean? Well, when we use mega, this means the factor, or what mega means, is 10 raised to the 6th power. That's what mega means, 10 to the 6th power. Kilo means 10 raised to the 3rd power. I'm going to skip down to milli. Milli is 10 to the minus 3 power. Micro, I hope you're starting to see a little pattern here, is 10 to the minus 6. Nano, 10 to the minus 9. Pico is 10 to the minus 12 power. I know, I skipped over deci and centi. So let's see here. So pretty much from like kilo probably down to milli in everyday commercial life around the world, these are probably the prefixes that people use in their everyday lives. Distance between home and work. What is the amount of water that they are going to drink? What is the dose of their prescription? How tall are they? Right? What is their body's mass? So these ones, kilo, the base, deci, centi, and milli, these tend to be in our functional everyday life. And then when you get beyond those, some of the larger ones beyond mega, you talk about when you're probably like pixelation and computer systems with storage and stuff, when you talk about giga and terabytes. And then getting smaller, okay, then you're probably talking about things that they're doing in the lab, or if it's concentration of very toxic items, very, very low concentration, or you're trying to measure the diameter of a cell or of an atom. So not used as much in our daily lives. So we have some slightly smaller increments. So the base is 10 to the 0, where deci is 10 to the minus 1 and centi is 10 to the minus 2. So outside of that, all of the other usable factors or prefixes, they jump by 3 going all the way up. So they max out at 10 to the 24 and 10 to the minus 24.